Bright Duty. Every student matters.
Now, let's go to the next one. That is, how are these electrons distributed in different orbits? Because Niels Bohr clearly stated that the electrons are revolving around the nucleus in discrete energy levels, and he named these levels as K, L, M, and so on and so forth. Now, there was an interesting question is how many electrons would be there in each of these energy levels? What is the possibility? Will all the electrons be in the same level? Can they jump from one level to the other? So this question really was put forward by different scientists and thought about. Ultimately, the actual distribution of electrons in different orbits were formulated. The following rules are followed for writing the number of electrons in different energy levels or shells. So these energy levels, according to Bohr, what are the energy levels? We have K, L, M, N, so on and so forth. K is associated with 1, L with the second shell, M with the third shell, N with the fourth shell, so on and so forth. So, according to this rule, it says, the first rule says the maximum number of electrons present in a shell is given by the formula twice n square. That where n is equal to 1, 2, 3, 4, so on and so forth. Now here what does it mean? That if you want to find out the number of electrons in each of these shells, then it will follow this formula of twice n square. Now let us see how much and how many electrons would be there. Suppose your n is equal to 1, the first shell or the K shell. So in K shell or the first shell, the number of electrons would be, in the K shell would be 2, here n is equal to 1, so 2 into 1 square, which is equal to 2. So the first shell will have 2 electrons. So it is going to be 2 into 2 square, which is equal to 2 into 4, that is 8 electrons. So your second shell will always contain 8 electrons. Similarly, for the third shell, that is M shell, 2 into 3 square, because n is equal to 3, which is equal to 2 into 9, that is 18 electrons. Okay. Whereas the fourth one, N shell, will be again following the same formula of 2n square. 2, n here is 4, so 4 square will be equal to 2 into 16, that is 32 electrons. And we will keep on continuing. So it clearly says that the first shell will contain 2 electrons, the second shell 8 electrons, third shell 18 electrons, and the fourth shell 32 electrons, and so on and so forth. The second rule says that the maximum number of electrons that can be accommodated in the outermost shell is 8. The third rule says that the electrons are not accommodated in a given shell unless the inner shells are filled. That is, first the N shell, N equal to 1 will be filled up, then it will go to the second shell, then to the third shell, fourth shell, so on and so forth. That is, the electron cannot abruptly keep on arranging itself in various shells. It has to follow its norm of first shell to be filled up first, then to the second, that is the L shell, then M, and so on and so forth. So these three rules clearly explained the number of electrons that would be present in different energy levels. The first rule clearly stated that it needs to follow the formula of twice n square, where n is 1, 2, 3, 4, so on and so forth. The second, that the outermost shell should always follow the octet rule. That is, the maximum number of electrons possible is 8. Exception, that it is only the K shell or the first shell which can hold only 2. But beyond that, all the shells needs to have maximum of 8 electrons. The third most important rule is that electrons cannot occupy any position. The arrangement of electrons would happen such that the first energy level gets filled up, then the second, then followed by third, fourth. Until unless the inner energy levels are not filled up, the electrons cannot jump to the higher energy level. So I hope this is clear that how are electrons distributed in different orbits.